Hey, what's going on YouTube? In today's Precursor video, I will explain some of the math behind the fragment shader which we're going to implement in the tutorial which will come out later today. To start with, let's look at the simple pipeline we will implement. If you recall from previous tutorials, if you want to render a triangle, you must pass 3 different vertices to a vertex shader. The resulting positions are then used to calculate the final rendered triangle. Just as we pass values from the loaded model to the vertex shader can calculate values and pass them to the fragment shader. The only catch is that one buffer is used to render each fragment, and because we pass 3 vertices to the fragment shader, we have 3 unique buffers. This is fine because the fragment shader only needs one buffer, and that would be the interpolated values between the 3 buffers. So to implement this, first you want to use the 3 vertices, the vertex shaders, to calculate the float buffers. Second, you want to store the floats in a dataless buffer. Then use the barycentric weights to interpolate between the values for each fragment. Then place those interpolated values into a buffer and pass that to the fragment shader to be rendered. The result of the fragment shader is the color of the fragment. Now let's talk about how we will interpolate these values. I mentioned previously that we're going to use barycentric coordinates. So what exactly are these barycentric coordinates? To put it simply, they're the weights of each vertex in a triangle which correlate to a single point within the triangle. We actually used this back in tutorial 2 or 3 when we calculated whether a point was in the triangle or not. Now because we have a weight for each vertex, we can calculate the interpolated values by using the interpolated x value is equal to x1 times w1 plus x2 times w2 plus x3 times w3. And the result can be used in the fragment shader. Of course, this is a simplified explanation, but I'll leave a link in the description providing a better explanation of barycentric coordinates. Now I'd like to share the naive approach for implementing this. It's actually a pitfall I fell in for a long time back when I did this project, and I had no idea what the problem was. So I started off logically. I just looped through each value in the vertex buffer and used barycentric interpolation to calculate the interpolated value. From there, I just passed it to the fragment shader. All that sounds like it should be correct, but in fact it's absolutely wrong. The problem stems from the z divide when we're converting the coordinates from a location on the perspective plane to a location on the screen. When we use barycentric interpolation in this manner, it is an affine space calculation, which means that the interpolation method assumes that each vertex is at the same depth. Of course, each vertex is at a different depth, so we need to account for that in the interpolation. Failing to do so results in strange warping effects in the lighting and texturing. Okay, so this seems like it would be a complicated problem to solve, but the solution is actually quite simple. In the corrected implementation, we can just loop through each value as in the naive approach, but instead we use the inverseZ values. We use barycentric interpolation to get the interpolated inverseZ, then we can interpolate the actual values as usual. The difference is when we store them in the fragment shader's buffer, we take the interpolated value and divide it by the interpolated z value. Doing so will correctly accommodate for the perspective shift and guarantee that every interpolated value is correct. Alright, so that's it for this precursor, and I hope to see you all in tutorial 12.